Good morning, guys. We're here at Futurecom 2013 at PromonLogicalis stand, and here we're showcasing a demo for SDN, Software-Defined Networking. The intent of this demo is to show a practical use case for SDN applied here for optimization of the network for the behavior necessary to enhance the experience on a given application. The application that we chose to show here is telepresence. Okay, so we have a telepresence system set up here and at a different stand over there. Okay, we're seeing this topology here, and this telepresence is interconnected by this network here. Okay, as you can see, the traffic is flowing through these routers over here at a good rate, 4 megabits. Okay, so you see good quality in this telepresence. What we expect to show with SDN is the capability to have an external application interact directly with the network and change automatically, or in this case manually also, the behavior of the network. So what I'm going to do here is first of all show you how we have this configured in the router. So we're going to see now the policy configurations that we're doing in the router through Cisco's 1PK, which is the newly released SDN software development kit offered by Cisco. So as we can see, we have established in this router here, R1, a rate of 6 megabits available for this traffic to flow through. And we have good quality in our video conference. Now, if I change this manually to, let's say, 768K, we're going to experience bad quality in this traffic, and we can see how our application automatically changed the configuration of the router as well. So now we have our session here has configured the bandwidth for 76800K, and we see bad quality in the conference. I'm going to switch it back now. All right, now it's good again. So our application here, which was developed on top of 1PK with collaboration and support by Cisco, interacts directly with the router and sets up different QoS characteristics in real time. And we can do this manually, which I'm showing here to you in the demo, and we can also set it up for auto mode, which is supposed to behave like this. We have here Cisco's TMS, the telepresence management system, where we can schedule several video conferences during this event. Okay, so our system is monitoring these scheduled events here, and will automatically also choose to set up the necessary configurations at a given time. Now let me show you a bit more about the topology of this. We have opted to use for these routers here Cisco's newly released CSR 1000V series, Cisco the Cloud Services Router. This is the first virtual router released by Cisco and behaves perfectly the same as any router. So all of this traffic here is being carried by virtual appliances running on virtual machines inside a server, which is pretty new, pretty exciting, and very easy to transport to our environment here. Now we have also a second use case that we want to demonstrate here. Our application is not only optimizing the quality here, but it is also choosing the best path for this traffic to flow through. How do we decide which one is the best path? We have a business rule, okay, an external business rule here in place, which shows me that provider A is charging me here $35 per megabit for this traffic, and provider B is charging me $37 per megabit. So the application is choosing the cheapest route by dollar, which is a very simple use case, but actually a very powerful one, because it shows the capability of adding intelligence on top of customized business rules that make up the decision online to fit the business. We can think of different use cases for this, and we can think of more intelligence that can be applied. How can this be? Let me show you a different system that we have here in place. which is another different development for us, which is a traffic monitor, an online real-time traffic monitor. So we're showing here in the different stages of the day the several video conferences that we have performed during the event, more recently over there. And we can also see the behavior of the traffic when we were going through route number 2 here at 10:45, and 5 minutes later the traffic goes down on route 2 and up on route 1, meaning that route 1 became cheaper than route 2. The application decided to change the traffic, and we see the behavior here in the interface of the router. So what we can do with this is add more automation and analytics on top of this, and we can monitor things like performance of the link, jitter, quality of service, packet loss, latency, and make more decisions and automatically choose the best route given these several sets of information, like cost, like the user that is behind the application, the type of application, and some quality needs. Let me finish this up by just putting up some better quality here. So this is it. Thank you very much, and I hope you enjoyed.